Hi friends, welcome to this channel. This is my first lecture and in this video I will introduce you with power electronics. Now, what is power electronics? Power electronics is a subject that deals with apparatus, equipments working on the principle of electronics but at high power level. So, basic difference between power electronic devices and electronic devices is the power which they handle. Power electronics in electrical world has main role to control the flow of energy from source to load. How these power electronic devices control the flow of energy? They control the flow of energy by controlling voltage, current and frequency. So, it is appropriate to state that power electronics is application of solid state electronics to control and convert the electric power. Power electronics era was started with invention of SCR in 1956. Now we will take some examples to explain the role of power electronics. Let's take this circuit. Here a DC motor is connected to DC supply and DC supply is 200 volts and speed of this motor is 500 rpm. Back EMF of this motor is 190 volt. Now we have to reduce the speed of this motor to 250 rpm. For that we use a conventional method. And what is that conventional method? We connect this external resistance in series with this motor. Okay, we know that back EMF of motor is equals to NP phi Z by A. So, keeping the flux constant, we can say that this back EMF is directly proportional to the speed of motor. When my back EMF was 190 volt, then my speed was 500 rpm. To get the speed of 250 rpm, my EMF will be 190 upon 2, that is 95 volts. So here the EMF gets reduced proportionally with the speed. Now we will apply KVL in this circuit. So when we apply KVL in this circuit, then we will get the drop across this external resistance. And what is the drop across this external resistance? That is this input voltage V minus this EMF E. So drop across external resistance will be 200 minus 95 volt, that is 105 volts. And this whole process, the power losses are associated with this external resistance. So what will be the power losses across this external resistance? These losses will be V square by R external, where V square is the drop across this external resistance. So we can say that this method is associated with losses. If we use some suitable power electronic device in place of this external resistance, then we can minimize these losses, because on state drop of power electronic devices is very less. I give you another example. In modern days, to regulate the speed of fan of your home, a very small circular regulator is used. That is triac based speed regulator. It is very small and efficient. But before that, large resistance based speed regulators were used. They were of large size because of more losses in them, due to which they have large heat sink requirements. That's why they were very large. So these two examples explain the role of power electronics. Now we will see advantage of power electronic devices. The first advantage is They are highly efficient due to less losses. They are highly reliable. They have long life and less maintenance. They have fast dynamic response compared to electromechanical systems. Their small size and less weight contributes towards their lower cost of installation. Now, disadvantages of power electronic devices. The biggest disadvantage of power electronic devices is the harmonics. They generate harmonics in supply system as well as load circuit. This is the biggest disadvantage of power electronic devices. Second is AC to DC and AC to AC converters operate at low input power factor. They have low overload capacity. That's why they are rated for taking momentary loads. Regeneration of power is difficult in case of power electronic converter systems. We know that biggest disadvantage of power electronic devices is harmonics. Now what are these harmonics? Harmonics are the non-fundamental components of current or voltage that are injected into the system. This happens due to switching or non-linear loads connected in the system. Due to this, current and voltage waveforms get distorted. This can be understood with this example. Here, suppose this is my desirable waveform. But what I get this waveform. We can clearly see that this waveform is distorted. Why this waveform is distorted? This is distorted due to harmonics. So we can say that due to harmonics, waveforms get deviated from sinusoidal nature. Now, this distorted sine wave can be represented as sum of DC component, fundamental component, and higher order harmonics. This analysis is performed by Fourier series. Suppose IST is a non-sinusoidal waveform, that is, non-sinusoidal current waveform. It can be represented as sum of this DC component, this fundamental component, this second harmonic component, this third harmonic component, and this fourth harmonic component, and so on. In this representation, only fundamental component is desirable, that is pure sinusoidal having frequency omega, and remaining all other components, that is this DC component and these all higher order harmonics, are undesirable components. Now, second harmonic component means it has angular frequency twice as that of fundamental component. Similarly, third harmonic component has frequency 3 times of this fundamental component. So, we have to write the RMS value of this current IST. So for that, what we will do, we will calculate the individual RMS values of all these components. The RMS value of this DC component is I0. RMS value of this sinusoidal component is Im1 by root 2. RMS value of this second harmonic component will be Im2 by root 2. And similarly, for this third harmonic component will be Im3 by root 2, and so on. So, to get the RMS value of this non-sinusoidal current IST, what we have to do? We have to square and add all these RMS values. So, we will square and add the RMS value of all these individual components. Then at last we will take square root of whole. So what we get? IRMS is equals to I0 square plus 1 by 2 Im1 square plus Im2 square plus Im3 square plus dot 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 so on, and under root of this whole. So only this Im1 by root 2 is desirable component. But what I get ReRMS is equals to this expression. So this expression clearly shows that my RMS value is greater than this Im1 by root 2, that is RMS value of this fundamental component. So we can say that, or we can conclude from this, that RMS value increases due to harmonics. Now what is copper loss? Copper losses are IRMS square into R. When IRMS increases, the copper losses also increases. And we know that power is equals to VRMS into IRMS into cos phi. So for constant power and voltage, if IRMS increases, then this power factor will decreases. So these are the three main disadvantages of harmonics, and this is really important. And these are: due to harmonics, RMS value of current increases, copper losses increases, and power factor decreases. That's all about this video. I hope you liked the video. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.